Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. Hi Arush, good evening. So I hope I am perfectly audible. So those who are watching the session, just mark your attendance here so that I can understand you are there or not. Okay, fine. Thanks for the confirmation. So finally, we are moving to the final discussion of the first chapter, chemical reactions and equations. I will be discussing the complete chapter in 1 hour. I'm including all the important topics here. So let's quickly start our session. So what are the important topics we have already studied in the chapter? Chemical reactions and equations. So these are the important topics, right? These are the important topics. What do you mean by the chemical reactions? Then how we can express the chemical reactions in terms of the chemical equations, right? Yes, first topic is the chemical reactions, the title of the chapter itself. Then chemical equation, what do you mean by the chemical equation? How to... Hi Durgeshwar, good evening. Yes, types of reactions, limitations and everything, right? So the chemical equations, right? How we can write down the chemical equations. Then the type of chemical reactions. Then what do you mean by the law of conservation of mass, right? Based on the law of conservation of mass, we are going to discuss about the balancing of chemical reaction, right? So we are going to discuss about the law of conservation of mass, types of chemical equations, balanced chemical equations, then how to write down the redox reaction, oxidation and reduction, to find out the oxidation state, and finally we will be discussing about the part of corrosion. You have already studied about these topics. I will be just briefly giving an idea about these topics. So let us start about what you mean by the chemical reactions, right? What do you mean by chemical reactions? So please try to be interactive, try to respond because we have already covered the chapter, just like a revision here. So what do you mean by the chemical reaction? Is there any chemical change happen? We can express in terms of the chemical reaction, right? So chemical changes are caused by the chemical reactions. So as we can see over here, this is the two components here, A and B combined to form an AB compound here, right? So these parts, the reacting species are known as the reactants, right? The reacting species are known as the reactants and the resulting compounds are known as the product, right? This will be our product. So this is the main part of a chemical reaction. The reactants are combined together to form single or multiple products, right? Yes, when chemical change happen, it is known as a chemical reaction. Yes, you are correct. Yes, reaction in which two or more substances react to form a new substance. That's also chemical reaction, right? So this is a part of a chemical reaction. Whenever you are explaining about the chemical reaction, you must have idea about what you mean by the reactants and what you mean by the products, right? So the reacting species are known as the reactant and resulting compounds are known as the product here. That is the same given here. The process in which more substances called reactants are converted to one or more different products. Okay, I hope you understand what you mean by the reactants and products. Now let us see how we can explain a chemical reaction in terms of the chemical change, right? First example, if there is any reaction that is involved in the evolution of gas, right? Evolution of gas. We have already studied what you mean by gases, right? There will be different types of gases, right? So when any of the reaction which contain at least one gas is evolved there, we can call it as a chemical reaction. Is there any example for that? Yes, gas, precipitate, color, temperature and state, which is already given here, right? Evolution of gas is a type of chemical reaction. Formation of precipitate, precipitation reaction, right? Then change in color, change in temperature, change in state. These we can explain in terms of a chemical reaction, right? SO2 and SO3. Yes, that's also an example, right? Let's see. What do you mean by the evolution of gas? So as we already know how to write down the chemical equation, right? We will be discussing later. But this is a type of chemical equation, right? These are the left hand side is representing the reactants here and right hand side is representing the products here, right? So here zinc and hydrochloric acid are the reactants. Then the zinc chloride and hydrogen are known as the products, right? So So in between reactants and products, there will be an arrow is present. That is a representation of a chemical equation. Yes, Arush, you are correct. I think you have already revised the chapter, right? So the reaction of zinc with dilute hydrochloric acid. So what you're observing here, zinc plus hydrochloric acid is forming the salt of hydrochloric acid, that is zinc chloride plus hydrogen. This arrow represents that this is a representation of a gas. Maybe you must have idea about this, right? So arrow mark means, this uphead arrow mark means the process of gas, right? It is the gas is evolving here. So which gas is evolved here? It is hydrogen gas, right? So we can call this as a chemical reaction because it is involving the formation of hydrogen gas. So this is one example, right? Now let us see what is the change. If you are forming the precipitate, how we can explain it as a precipitation reaction or the chemical reaction, right? So what is the reaction here? What are the reactants here? What are the reactants here? Silver nitrate, right? Silver nitrate, yes, silver nitrate plus sodium chloride. So the reaction of silver nitrate and sodium chloride is forming silver chloride, right? I have already given a color is white here, which means it is forming a precipitate of white color. So in the chemical equations, there will be different meanings for different arrows, right? This will be representing the arrow corresponds to the reaction side, right? Then this arrow represents the gas is evolved here. Then if the arrow is down, you can note it as precipitate. Clear? So here AgCl, which means silver chloride, is known as the white precipitate here. In this reaction, the precipitate happened. I mean, precipitate is forming, right? So this reaction is known as the precipitation reaction. Is that clear? Okay, fine. The next type of reaction, how we can explain in terms of the change in color, right? So what you're observing here, I have already changed the color here. Do you have any idea about this? Which is the color change here? This is the reaction of iron with copper, right? Iron with copper. So iron is treating with copper sulfate. It is forming ferrous sulfate plus copper. Yes, blue to reddish brown, right? Yes, obviously. So in the case of this reaction, copper sulfate, as we already know, it will be having a blue color, right? It will be having a blue color. So what is experiencing here? This blue color copper sulfate is changed into a reddish or brown color of copper, right? Reddish or brown color of copper. Then again, in the case of ferrous sulfate also, we can change the color, right? Green, it's fine. So in major, we can see the color difference here in the case of copper sulfate to copper, right? Copper sulfate, if you are taking copper sulfate in a beaker, it will be having a blue color. If you are pasting a metal rod, I mean iron rod over there, after few times, the color of the solution will be changes to red or reddish brown. Clear? So by the change in color, we can explain a chemical reaction. Okay, I hope you understand. As this is the type of displacement reaction, right? We are going to discuss about the type of chemical reaction. So this is the type of displacement reaction. So what you're observing here, which metal is displaced here, iron or copper? Hardik? Yes, iron, right? Iron or copper? So what are experiencing here? The iron can displace the copper from the copper sulfate. So copper is get displaced here. Let us discuss later in terms of displacement reactions. The next type is the change in temperature, right? If you are changing the temperature, how we can explain in terms of the chemical reaction. So what are experiencing here? What do you mean by quicklime? Calcium oxide is known as the quicklime. So whenever quicklime is treated with the water, you will be forming the CaOH twice. Slaked lime, right? Plus heat. So what you're observing here, heat is released, right? Heat is released here, which means temperature is changing, right? Temperature is changing or heat is released. Such type of reaction is known as the exothermic reaction. Then what we will call it as if its reaction is absorbing the heat. So this is the type of reaction in which the change in temperature happens. So whenever we are discussing about the reaction of quicklime with the water, it will be forming the slaked lime along with heat, right? Heat is releasing. If the reaction contains the heat is releasing, which will be called as the exothermic reaction, heat released. If any of the reaction in which heat is absorbed, such type of reaction are known as the endothermic reaction. Yes, Arush, in case of iron also this color change happened, but majorly we will be discussing about the copper sulfate change, right? In the case of copper sulfate, blue is changing to reddish brown. Okay, I hope you understand here. Yes, addition reaction, right? Now the last case is the change in state, is the reaction happening in the change in state. So what you are observing here, which state is changing here? Reaction of carbon monoxide with hydrogen gas. Both carbon monoxide and hydrogen are in the gaseous phase, right? These are the gaseous phase. Then whenever these are treated together, they will be forming a liquid methanol, right? Liquid methanol, which means that the physical state is changing here. Clear? Yes. So how we can explain a chemical reaction, whether it is having the change in temperature, change in state, change in color, precipitate formation, or change in or evolution of gas also, right? Evolution of gas also, we can say it as a chemical reaction. Now let us discuss about how we can explain a chemical reaction in terms of chemical equation. So how we can explain chemical equations? We have already seen, right? Whenever we are discussing about the chemical reaction, we have already seen how we can explain the chemical equations, right? There will be a plus sign. Reactants are combining to form product. There will be a rightward arrow is present, right? Rightward arrow is present. So for example, if we are taking here HCl plus sodium, it will be forming sodium chloride plus hydrogen. So this left hand side is known as the reactants, right? HCl and sodium are the reactants and sodium chloride and hydrogen are the products here. So this will be our right-handed arrow, which is helping us to understand the rate of, place of the reaction, right? Reaction is going towards here. So plus sign is already here, arrow is here, reactants and products. so that we can explain the chemical equations. Clear? Now there will be two methods to write down the chemical equation, either in word equation or the chemical equations, right? So how we can explain the word equations? We are just using the names of the substance. For example, if I am taking hydrogen plus chlorine is equal to hydrochloric acid, right? So I am just writing hydrogen plus chlorine is equal to hydrogen chloride or hydrochloric acid in terms of word. Similarly, I can write down the same equation in terms of chemical symbols, right? Hydrogen is here, chlorine is here, it will be forming the HCl. This is also same, right? So what will be the limitation of this word equation? So it is very difficult to write down the complete names here, right? So less precise and more descriptive. Then does not indicate the balancing here. We can't explain the balancing equation here, and it is easier to understand for the beginners. So these are the main important points for the word equation. But whenever we are writing about the Durgesha, we are going to discuss about the type of chemical reactions, right? Then whenever we are writing about the chemical equations, it will be used in the chemical symbols, right? It's just like hydrogen and chlorine, it is given hydrogen chloride. It is understood, right? So this is more precise and includes the exact ratio. For example, if I am taking the balanced chemical equation, I can understand 1 mole of hydrogen is reacting with 1 mole of chlorine to form 2 mole of HCl. So it is understood, right? Must be balanced to follow the law of conservation of mass, and it requires the knowledge of chemical formulas. These are the main importance or the important points difference between word equation and the chemical equation. Okay, in terms of chemical equation, we can just call it as two type of chemical equations. One is atomic equation and another one is the molecular equation. So if we are writing down in terms of atoms only, we can call it as the atomic equations. Or if we are taking in terms of the molecular form, we can call it as the molecular equation. There is no any specified classification for the chemical equations. Durgeshwar. Now we need to learn about why we are balancing the chemical equations, right? Why we are balancing the chemical equation. The basis of balancing of chemical equation is known as the law of conservation of mass. Arish, what do you think about the endothermic reaction? Heat energy is absorbing, right? So what is happening to the energy, whether it is decreasing or increasing? You can think about that. So what do you mean by the law of conservation of mass? You have already studied, right? Mass is conserved here, which means that if you are taking any of the chemical reactions, the total mass of the reactant should be equal to the total mass of the product. Clear? Same, we are taking the same equation here. So what about the mass of hydrogen here? As law of conservation of mass can be explained in terms of energy can neither be created or not destroyed. It's the law of conservation of energy, which we have already discussed in the physics. Here it is discussing about the law of conservation of mass. Mass can't be created nor destroyed. Okay, in the case of hydrogen plus chloride, it is forming HCl, right? So if I am taking the mass of hydrogen here, it is 2 grams, right? One hydrogen is 1 gram, here it is 2 grams. Then for one chlorine atom, it is 35.5 gram. So if I am taking 2 chlorine atoms, it is 2 into 35.5, that is equal to 71 gram, right? Just for a representation I am giving here. So now if you are taking here, So what is the mass of this complete HCl is here? This 1 plus 35.5, right? This is equal to 36.5 gram. So according to our law of conservation of mass, we know that we need to consider the mass of reactants and mass of product, right? It should be equal. But here it is 36.5 and here it is total. How much it is? 71 plus 2, 73, right? Total it is 73. So I'm writing here. It is 73, right? But in the case of product, it is equal to 36.5 only. So we can just adjust the equation by multiplying by 2, then it will be forming 73, right? So this is the basics of balancing chemical equations by using the law of conservation of mass. Is that clear? So here it is a simple explanation of the law of conservation of mass. Just like law of conservation of energy, here it is mass is conserved, right? It's not matter, this mass. Now how we can balance the chemical equations, right? So as we already know, there will be reactants, that are the substance undergoing the reaction or the change, right? Then new substances are forming, they are known as the products here. So for example, if I am taking this reaction, that 2 Mg plus O2 gives 2 MgO. This is a balanced chemical equation, right? Okay, while explaining about the balancing of equation, I will be explaining the stoichiometric coefficient, fine. So 2 Mg plus O2 gives 2 MgO. This is known as the balanced chemical equation for the reaction of magnesium and oxygen, right? 2 Mg plus O2 gives 2 MgO. So now what is the coefficient of magnesium here, Durgeshwar? So here it is 2, right? In the case of magnesium, it is 2. In the case of hydrogen, there is simply 1. So in the case of magnesium oxide, it is 2. So this is a simple explanation for the stoichiometric coefficient. Alright, so here these are the reactants and these are the products. So this is the balanced chemical equation. So for example, if we are just writing the equation as Mg plus O2 gives MgO, we can call this equation as a skeletal equation. The same equation if I am doing like this, magnesium plus oxygen form magnesium oxide, right? So this is known as the skeletal equation. We can just give an idea about that. These are the reactants, these are the products. So if you are putting the stoichiometric coefficients over there, we can call this as a balanced chemical equation. So again, it is representing here what you mean by the skeletal equation, right? Skeletal chemical equation. If the number of atoms of each kind is not equal on both sides, that equation is known as the skeletal chemical equation, right? So simply we are writing magnesium plus oxygen form magnesium oxide. This is the unbalanced chemical equation or the skeletal chemical equation. Now we can balance this equation according to our law of conservation of mass, right? How we can balance this? We have already seen, right? Clear? We are just balance the equation by multiplying 2 here, so you will get the correct answer here. Now let us see what is the essentials of a chemical equation, right? How we can express the chemical reactions in terms of the chemical equation. So you must represent a true chemical equation. From the chemical equation itself, you must understand about what is the reactants there, what is the products there, right? Then must be balanced according to the law of conservation of mass, right? Law of conservation of mass. Then the reactants and products should be written in the correct formula form. So this is the basic essential for a chemical reaction to be written. So if you are writing any chemical equations, to identify the chemical reaction, you must return the reactants and products along with their physical state. Then write down the balanced chemical equation. Now how we can balance the chemical equation by using hit and trial method, right? Maybe you have studied about the hit and trial method. There is nothing to worry. We can just identify the unbalanced atoms, right? Then adjust the coefficients step by step. Then verify the conservation of mass. These are the important steps, right? These are the important steps for the hit and trial method. We are just find out the unbalanced atoms over there. Then adjusting the coefficients by step. Then we need to add the masses to verify the law of conservation of mass. Let us see an example here. So try to solve this question to balance the equation. So you can use your own method, just get the coefficients of these. These are the coefficients, right? A, B, C and D here, and here it is given the word equation. First you need to convert the word equation to the chemical equation. Identify the coefficients A, B and C, A, B, C and D given here. Options are given here. Try to solve the question. Okay, now you can give me the options. Yes, energy is increasing in the endothermic. System is absorbing now, so it will be increasing. So maybe you will be studying in detail in the thermodynamics part in grade 11. Then you will get a better idea about that. So what will be the answer for this question? How we can balance the chemical equation? Here, how to find out the coefficients? Okay, is there anyone got the answer as option D here? A is equal to 3, B is equal to 2 and C is equal to 2 and D is equal to 3. Anyone got the correct answer here? Okay, I will write down here. So what is the chemical formula of lead nitrate? How we can write down the chemical formula if the word, okay, if the word is given, this lead nitrate, right? How we can write down the chemical formula? So you must have idea about the cations and anions formed here, right? SpBNO3, right? P should be capital and N should be capital whenever you are writing the chemical formula here, right? So in the case of lead, I will write down here. This is our lead, right? This is a symbol for lead, and nitrate it is NO3. So you must have idea about the valencies of these metals here. So in terms of any of the chemical compound, there will be having the positively charged ion as well as a negatively charged ion. Positively charged ion is known as the cation and negatively charged ion is known as the anion, right? So if you are writing here, this is lead is the cation, right? Because it is having the +2 charge. So Pp2 plus, right? Then this is NO3 minus. So how we can write on the chemical formula? Just crisscross the valencies, right? I am writing here Pb NO3 valency. We don't want to consider the charges here, right? So I am writing 2 here, 1 here. Crisscross the valency, right? So it will be forming PbNO3 twice. Clear? Durgeshwar, it is PbNO3 twice, not simply PbNO3. Is that clear how to write down the chemical formula if the word is given? Now tell me what is the chemical formula for the aluminum chloride? Okay, Hardik, you are correct. PbNO3 plus AlCl3. Okay, I will write down here. So this is the chemical formulas, right? We are just crisscrossing the valencies. So how we can write down the chemical equation here? It is PbNO3 twice plus AlCl3 gives AlNO3 thrice, right? Plus PbCl2. So this is our skeletal equation, right? I'm just removing these things here. I hope you understand. So this is the skeletal equation, right? Now we need to balance this equation. How we can balance this equation? No, Arush, just take here, right? Aluminum and chloride, right? Aluminum and chlorine. As we already know, in the case of aluminum, valence is 3 plus. And chlorine, it is minus 1. So if you are taking the valences, if you are crisscrossing, you will be forming AlCl3. Is that clear? And Hardik, there is a small correction in your equation given there. It is PbNO3 twice, not PbNO3 itself. Okay, I hope you understand. So this is the skeletal equation. PbNO3 twice plus AlCl3 gives AlNO3 twice plus PbCl2. Now we need to balance the atoms, right? We need to balance the atoms, or we need to completely balance the chemical equation here. So simply we can just consider, we can't go for the complete hit and trial method. Just consider the maximum number of compound given here. Just compare here. This is our reactant side, right? Okay, I hope you are getting the point. If not, just let me know. So here, if you are considering the maximum number of component here, both in reactant side or product side, which one it is there? Not in the terms of atoms, we can just consider the lead as a part, nitrate as a part, aluminum as a part, and chlorine as a part. So which one is the maximum here? So if I am considering the NO3 part only, right? Here it is 3 NO3 part present in the product side. So which is maximum. Now first we need to balance this NO3 part. So how I can balance the NO3 part? It is already 3 here. Here it is 2. So both of them we can just balance by taking 6 as the common ion here, right? So I am just multiplying it with 2. Okay, I hope you understand. Is there any doubt? So first we need to consider the component which is present in the both reactant or product side in the maximum number. So I am just considering here nitrate is present in the 3 times as compared to the reactant part, right? So I need to balance the number of NO3 minus here. Then here it is 3 NO3 minus, here it is 2 NO3 minus. We can't balance directly, right? So I am just multiplying with the 2 in order to make them 6. Is there any doubt? Now in the product side, NO3 part is already balanced, right? 2 into 3. But in the case of reactant side, it is only 2 NO3 minus is present. So I am multiplying here 3 PbNO3 twice. So total NO3 is balanced here as 6. Okay, I hope you understand. Now what is the remaining atoms here? If you are considering the reactant part, 3 PbNO3 twice plus AlCl3, right? Already NO3 is balanced in both the reactant and product side. Then the remaining is 3 lead atoms, right? 3 lead atoms. So I am putting 3 here to balance the lead atoms in the product side. Okay, I hope you understand. Now we have already balanced the lead and nitrate together. Now we need to balance the chlorine atoms, right? So here 3 into 2, 6 chlorine is present. But in the case of aluminum chloride, there is only 3 chlorine, right? Then again, if you are considering the aluminum atoms, the product side it is 2. So here we need to consider 2 aluminum again in the reactant side. Okay, I hope you understand how to balance the chemical equations, right? Just consider the maximum number of components in the reactant or product side. Start from the balancing there. Then adjusting the numbers to balance the atoms. So this will be the final balanced chemical equation, right? 3 PbNO3 twice plus 2 AlCl3 gives 2 AlNO3 twice plus 3 PbCl2. Here A stands for 3, here B stands for 2, C stands for 2 and D stands for 3, which means option D will be the correct answer. Is that clear? So balancing of chemical equation is very important in terms of the first chapter. So you can try by yourself by balancing all the chemical equations. Try to solve by using this method. Now we will be discussing about what are the type of chemical reactions, right? What is the type of chemical reactions? So as we already know, there will be the breaking of bonds happens or the formation of new bonds happens, right? Two types of reaction will be happen. There will be breaking of bonds will be happen or the formation of bonds will be happen. Depending upon the terms, we can just define or we can just classify the types of chemical reactions as first one, it is the combination reaction. So what I mean by combination reaction? Any idea? So what you're observing here, I'm taking two of the reactants, right? Yes, combination, decomposition, displacement, addition reaction, right? These are the main important types of the chemical reactions here. So we are discussing about the combination reaction. For example, if I am taking two reactants A and B together, they will combine to form a single product AB, right? Single product AB. So we can just define the combination reaction as two or more reactants combined to give a single product. Clear? Single product. A and B is combining to form a single AB product. So here we are synthesizing the AB, right? We are synthesizing the AB. So this reaction is also known as a synthesis reaction. Is that clear? What do you mean by the combination reaction? Yes, at least two reactants should be there to combine, or more than two reactants also combine to form the single product. Durgi said there is a correction. It is not the chemical reaction. These are the reactants. Now let us discuss about the next type of chemical reaction, that is the decomposition reaction, right? Just opposite of the combination reaction, right? So if you are taking here, in previous case we had discussed A plus B is forming AB, right? A plus B is forming AB. Now if I'm taking the single product AB, I'm just breaking this, right? So it will be forming the products A and B here. So this is a synthesis reaction and the second one is the decomposition reaction, right? So this is just opposite of the first reaction or the combination reaction. Is that clear? So we can just connect the synthesis of the combination reaction together with the decomposition. Decomposition reaction is just reverse or the opposite of the synthesis reaction or the combination reaction. And again we can explain the decomposition reaction in terms of this also, right? If you are taking the symbol or single component with the parts A and B, C together, it will be destroying to form A, B and C differently, or AB plus C. These are also type of decomposition reaction, right? Okay, Arush, do you have any example for the such type of reaction? Right now, I don't have any example for that. Okay, see. Now, next type of reaction is the displacement reaction, right? We have already seen while explaining about the charge change, we have seen the displacement reaction, right? So we can just say that here A plus BC is forming AC plus B. So what are observing here? A can displace B from the solution of BC, right? B is displaced by A. So from this equation or from this type of reaction, we can just explain the reactivity of these metals or these components, right? So what you're observing here, B is displaced by A, right? Which means A is more reactive than B, right? We have already discussed about the reactivity series in the metals and non-metals chapter. So we can easily identify the type of displacement reaction depending upon the reactivity series, right? So here, A is more reactive than B, so that A can displace B easily from their solution. Just like we have discussed in the case of Fe plus copper sulfate. Now this is a single displacement reaction, right? So some other cases, double displacement also happen, right? There will be two methods or two type of elements can be displaced here. So what are observing in this reaction? This is AB type, right? This is AB type, this is CD type. So it will be forming AD and CB. So what are observing here? It can displace more than one atoms, right? So one of the ion in a reactant molecule is more reactive and displaces the other ion in another reactant molecule to form products, right? This is our one of the reactant, this is another reactant. So one of the ion from this reactant, that is B, right? B is displacing from here and here D is displacing. So such type of displacement reaction is known as a double displacement reaction. Is that clear? Hi Manish. So I hope you understand about the double displacement reaction. So this is a major important type of the chemical reactions. Now we will be discussing about the redox reaction. Redox reaction means it will be happening. In the case of such type of reaction, there will be oxidation as well as reduction happens, right? So first we need to identify what you mean by the oxidation. So how we can explain an oxidation reaction? Anyone? What do you mean by oxidation? How we can explain a reaction, whether it is an oxidation or not? So there will be such method, right? There will be some method to identify whether the reaction is oxidation. First, we can explain if hydrogen is removed from there, right? If hydrogen is removed from there. So removal of hydrogen or addition of an electronegative element or the removal of an electropositive element. So such type of reactions we can call it as an oxidation reaction, right? So just consider this first reaction, right? H2S plus Cl2 gives 2HCl plus S. So what are you observing here? Is there any hydrogen is removing? Is there any electronegative element is adding or not? Yes, Hardik, you are correct. We can explain in terms of addition of oxygen, right? Yes, this is a classical concept. So if I am considering this reaction, this is H2S, right? So hydrogen is removed here. Simply sulfur is forming. So we can explain this as a removal of hydrogen as an oxidation. Or otherwise we can call it as, this is a electronegative element, right? Chlorine is an electronegative element we have studied in the periodic table part. So here it is an electronegative element. If you are adding an electronegative element, again we can call it as an oxidation, right? Again we can call it as an oxidation. So simply there is another example. 2Fe plus 3F2 gives 2FeF3. We are adding electronegative element fluorine here. And in the second reaction, Mg plus Cl2 gives MgCl2. We are adding another electronegative element, chlorine, here to form the magnesium chloride. Is that clear? So these are the classical concept. Then when we are discussing about the electronic concept, right? If you are discussing in terms of the electrons, we can call these oxidation reaction as the loss of electron. We are just losing the electron, right? So what you are observing here? Zinc is losing 2 electrons to form the zinc 2 plus ion. So again we can explain this reaction as an oxidation. Then if you are explaining in case of S2O3 2 minus, so what you are observing here? S2O3 2 minus is changing to S4O6 2 minus by losing 2 electrons. So these are the major concepts behind the explanation for the oxidation, right? Removal of hydrogen, addition of an electronegative element, or removal of electropositive element, or the addition of oxygen. We can just remember here oxidation, right? We are adding oxygen. Is that clear? Now, what will be the concept of reduction? Just opposite, right? In oxidation, we are adding oxygen, but in a reduction, we are removing oxygen and adding hydrogen, right? Adding hydrogen. Similarly, we can call it as removal of an electronegative element or the addition of an electropositive element. Let us see by examples here. So, what are observing here? 2FeCl3 plus SnCl2 gives 2FeCl2 plus SnCl4. How we can explain this as a reduction reaction? Only two more concepts, I think. We need to identify the oxidation states, right? We need to identify the oxidation state, how to calculate the oxidation state. And lastly, we will be discussing about the corrosion. Yes, inverse of oxidation, right? Inverse of oxidation. So, chlorine is removed from here, right? Chlorine is removed from here. Chlorine is an electronegative element. So, we can explain this reaction as a reduction reaction because it is involving the removal of an electronegative element, right? Then, if you are asking about the electronic concept, right? Electronic concept, we can call this as a gain of electron, right? In the case of oxidation, it is loss of electron, but in the case of reduction, it is gain of electrons, right? So, Al3 plus is gaining 3 electrons to form the aluminum metal. And similarly, if you are explaining here MnO4 minus permanganate ion, right? So, it will be gaining or adding 5 electrons to form the Mn2 plus 4 water. Clear? So that we can explain the oxidation reduction in terms of these concepts. Okay, Hardik, I think you have studied using this mnemonic, right? Oxidation is loss of electron and reduction is gain of electrons, right? Okay, there will be majorly 3 concepts we have just studied about the oxidation terms. If you are asking about the terms of hydrogen, addition of hydrogen or addition of oxygen, we can call it as a classical concept. Then if you are explaining in terms of the electrons, we can call it as an electronic concept. Then if you are studying about the oxidation state, we can explain this oxidation or reduction in terms of oxidation state concept also. It is known as a modern concept. Clear, Arush? Now we are going to explain the oxidation state, right? How we can explain or how we can calculate the oxidation state of a particular element given in a compound, right? So for example, I am taking HAuCl4, right? So which are the atoms or elements given here? Hydrogen, gold and chlorine, right? Au stands for gold here. So we need to identify the oxidation state of gold given here. So I am taking the unknown oxidation state of gold as X here, right? So as we already know, if you want to count down or if you want to find out the oxidation state of a compound, it will be equal to the sum of oxidation state of individual atoms present there, right? So in the case of hydrogen, in general, hydrogen is having the oxidation number of +1, right? Is there any doubt? So while discussing about the oxidation state part, we have already discussed many rules, right? How to find out the oxidation state for the single elements depending upon the group. It's already given in your textbook. Just refer there. So here, in case of hydrogen, it is +1, right? It is +1. Then what about the case of chlorine? It is a negatively charged element, right? Chlorine is a negatively charged element. So it is the having the oxidation state or oxidation number of -1, right? So as we already know, in order to find out the oxidation state of this complete compound, we need to add the individual oxidation state, right? So I am taking here, it is +1 stands for hydrogen, X is for the gold, and 4 into -1 for the 4 chlorine atoms, right? So it will be equal to sum. So if you are solving here, you will get the answer of X is equal to +3, which means that the oxidation state of gold in this compound is plus 3. Is that clear? Is there any doubt? As it is based on the valencies, but in some particular case there will be some exceptions. It is already given in your NCERT textbook, just refer there, right? So in terms of hydrates, hydrogen will be explained in terms of -1. Generally hydrogen is having the +1, right? But in case of hydrates, they will be act as a -1 oxygen state, and there will be some exception for the oxygen also. So just refer in your textbook, it is there. Exceptions are very important in terms of chemistry. Now what about the case of second compound, TL2, right? So I need to identify the oxidation state of TL here. Here 2 TL is present, right? 2 TL is present. So I'm just adding the individual oxidation states here. So it will be equal to 2 into X, right? I'm taking X as the unknown value. So 2 into X, oxygen, general oxidation state of oxygen is -2, right? It is -2. So 2X minus 2 is equal to 0, or X is equal to +1, which means that the oxidation state of thallium in case of this compound is +1. Is there any doubt? It's not given there. Okay, I don't remember all the things. I will just give an idea. Hydrogen is -1 case of hydrides. So I hope you can see the difference, right? So for example, if I'm taking K2 as one of the molecule, right? K2 as the one molecule. So this is known as a superoxide, right? Superoxide. So as we already know, for potassium it is 2, right? Potassium it is 2. I mean for one potassium it is +1. So 2 potassium it will be 2. So I'm taking 2 plus X is equal to 0, right? We need to identify the oxidation state of oxygen here. So it will be 2 plus X is equal to 0, or X is equal to -2. So in the general case, right? So there is one more explanation. See, this is a general oxide and this is a superoxide, right? This is a superoxide. Then another case it is peroxide, right? If I am taking H2O2. So it will be 2 hydrogen, it is 2 plus 2X is equal to 0, or X is equal to -1. So these are the major things I remember right now. Exceptional cases. Okay, in the case of iron also we will be having different valencies, but major concern is about the case of oxygen. Depending upon the compounds forming, oxygen is having the 3 different oxygen states. Generally it is -2, and for superoxide it is -1/2, and for peroxide it is -1. This is peroxide. Okay, I hope you understand. Okay, in general copper is having the +2. Aluminum is +3, right? Now we will be discussing about the last part in the chemical reactions. It is about the oxidation in real life, right? Oxidation in real life. You have already seen the rusting of iron, right? Rusting of iron. So if you are using any of the metal part as the iron here, after some time, after some use, it will be having a brown color over there, right? It is getting corroded, right? So this process is known as the corrosion. So what is the chemical reaction between the corrosion, behind the corrosion? So iron metal is reacting with the moisture or oxygen present in the atmosphere to form such hydrated forms, right? So this is known as the corrosion reaction. In terms, we can write it as the 2Fe plus 3/2O2 plus XH2. It will be different molecules. So it will be forming Fe2O3 dot XH2O. This is known as the rust, which will be seen in the form of a brown color. Clear? This is known as the rusting of iron. This is a common example for the corrosion we have studied. So is there any other example for the corrosions? I think we have already studied in the third chapter also, right? Metals and non-metals. Yes, in the case of tarnishing of copper, right? Environment moisture attack on the substance. Yes, that is the explanation for the corrosion. Tarnishing of copper is again example for the corrosion, right? Which means if you are using any of the copper plates or something, after some time it will be having a blue color because of the presence of the copper compound over there, right? Copper carbonate over there, that is known as the tarnishing of copper. Then finally we have discussed about the tarnishing of nickel is also fine. Finally, we have discussed about the how to prevent the corrosion, right? We can just use the galvanizing over there. We can just use the paints over there. It is a method to remove the corrosion, right? So this is the general example for the corrosion here. Iron corrosion is in the presence of moisture and oxygen. This is the responsible compound, the Fe2O3 dot XH2, responsible for the reddish brown color. Then in the case of aluminum, moisture is reacting from Al2O3, right? So it will be forming a silvery white color over there. What about the case of tarnishing of copper? Damp air and the carbon dioxide, simply air, right? Plus, COH twice and moisture will be the compound responsible for the tarnishing of copper. It will be representing a greenish yellow or greenish blue color is representing there. Then in the case of magnesium also same, carbon dioxide and air. MgOH twice, it is forming a greyish white color over there. And the last case it is about the silver, right? Silver is reacting with the air and H3. Air and H2S to form the Ag2S, which is in the black color. So this is the most common example for the corrosion, which is we have discussed in the classes. Clear? Okay, that's all about from my side for today. I hope I have completed almost all the important topics in the chemical reactions and equation chapter. So, okay, I hope you guys enjoyed the session. If you really like the session, hit the like button, subscribe our channel, share this particular session to your friends also. It will be helpful for them also. So, thank you so much all of you. See you in the next class. Bye-bye.